Alright, so we have this parabola that opens to the right, and again, I will try my best to explain to you the different parts of these parabola, locate them, and how they relate to each other. Alright, so if you're curious about what if the parabola opens upward or downward, well, I have those videos in my YouTube channel, so you can check those videos and compare those videos to this parabola. Alright, so first, let's name this parabola. This is y minus 6 squared equals 4 times x plus 5. So this is the graphical representation of that, this parabola that opens to the right. And again, two things we need to remember. Number one, if the one with the square is the variable y, you can see that here on the left side, it opens to the left or to the right. This one opens to the right because if you look at the right side of the equation, it's positive. Once you see -4, maybe -5, -6, whatever number is there, as long as it's negative, the parabola is going to open to the left. And obviously, you already know this. If P, we will solve this, it's going to be positive. It will open to the right side, provided that the one with the square is the variable y. So let's solve for P first. This is the general equation for that. So 4p equals 4, p equals positive 1. Now let's locate where is the vertex first. It's at -5 and positive 6. We can clearly see that from our equation. And then, of course, we have this imaginary line. This time it's horizontal that divides the parabola into two equal parts. We call that the axis of symmetry. So in this case here, unlike when the parabola opens upward or downward here, that depends on the value of our k. So axis of symmetry is equal to y equals k if the parabola opens to the right or to the left. Now let's locate the focus. That focus, we will use the value of p. So p is 1. That means the focus is 1 unit away from the vertex. So that means it's somewhere here. Now if we don't have the graphical representation for that, there's a formula. So that's h plus p. H is -5 plus 1 is -4. So let me just write that. -5 plus 1 is -4. And the k is the same as the k of our vertex. So that means that's this. All right. And then, of course, we have the directrix, and that's this one. Again, the distance of that from the vertex is equal to the absolute value p, which is 1. So we can clearly see it's at -6. X equals -6. But if we don't have the graphical representation, we can use the formula x equals h minus p. H is -5 minus 1 is -6. I think I need to write that here. -5 minus 1, that equals -6. Right? There you go. So let me just erase this and write that -5 minus 1 on top. And of course, I want to emphasize this distance of the vertex to the directrix is equal to the distance of the vertex to the focus, and that's equal to the absolute value of p. Now let's move on and locate the ends of the LR, or latus rectum. So let's start with the one on top. That's that one. Whatever the x coordinate this time of the vertex of the focus, which is h plus p, they're the same. Okay, and then for the k, it's going to be different. So k is, or the y coordinate is equal to k plus 2p. So k is 6 plus 2 times 1. Okay, let me just write that down here. All right, so k, which is 6 plus 2 times 1. That's 8. All right. And then the other end is right here. Okay, that's the formula. So if it's the end of the LR on top, it's k plus 2p. If it's down there, the other side, it's k minus 2p. For the x coordinate, it's the same as the x coordinate of our focus. So k is 6 minus 2, which is 4. So that's -4 and positive 4. And of course, I want to emphasize this. The length of those two ends of LR, that's equal to the absolute value of 4p. In this case, 4p is 4, right? So that's 4.